Have you ever really stopped to wonder what a rainbow is? I mean, you see it, this giant, perfect arc painted across the sky. It feels so real, like you could almost reach out and touch it. But the truth? Well, the truth is way more fascinating and a lot more mysterious. Okay, let's dive in.
So get this, a rainbow isn't a physical thing at all. This quote just nails it. Unlike a mountain or cloud, a rainbow has no actual spot in the world. And here's the part that'll really blow your mind. The rainbow you're looking at is yours and yours alone. The person standing right next to you, they're seeing a completely different one, made just for them.
So that leads us to the big question, right? If it's not an object, if it's not really there, then what in the world are we seeing? Well, the answer is this incredible mix of physics, geometry, and, well, you.
The first thing we need to do is kind of flip our whole understanding. A rainbow isn't a thing, it's an optical effect. It's an event, one that completely depends on where you are standing at that exact moment.
This right here breaks it down perfectly. What we think we see is this physical arc hanging in the sky. But what's really happening is an optical illusion that's totally unique to your perspective. That's why you can never reach the end of a rainbow, because as you move, it moves with you. The entire event is literally centered on your eyes.
So how does this amazing personal light show get made? It all comes down to a very, very precise arrangement between three key players: the sun, some water droplets, and, of course, you. You can almost think of it like a recipe. First, the sun has to be at your back. Second, there has to be a curtain of water droplets, like rain or mist, in front of you. And if any part of that setup changes, say you turn around or a cloud blocks the sun, poof, the rainbow just vanishes from your sight. And hey, we're not just talking about big rainstorms here. Those water droplets can come from anywhere. The mist off a waterfall, the spray from a garden hose, even a really thick fog. As long as the geometry between the sun, the water, and your eyes is just right, a rainbow can appear.
All right, to really get how this all works, we need to zoom in, way in. We need to look at what happens when one single ray of sunlight hits one single tiny droplet of water.
The first key idea here is something called refraction. You see, when light goes from the air into the water of a raindrop, it actually slows down a bit and changes direction. It bends, and that very first bend is step one to creating all those amazing colors.
So the journey for that little ray of light is a four-step dance. Step 1, it enters the droplet and bends. That's refraction. Step 2, it travels to the very back of the droplet and bounces off the inside surface, kind of like a tiny mirror. That's reflection. Step 3, it heads back to the front and exits, bending one more time as it goes back into the air. And all that bending and bouncing sets the stage for the grand finale. The light spreads out into a full spectrum of color.
And here is the absolute key to the whole thing. Not all light bends the same. Sunlight looks white to us, but it's really made of all the colors mixed together. When that white light passes through water, each color bends at a slightly different angle. Red light bends the least, and violet light bends the most. This whole process of splitting white light into colors is called dispersion.
Okay, let's zoom back out. So that whole light splitting process is happening in millions and millions of droplets all at once. But why does it form a perfect arc? Well, this is where a little bit of geometry gets really important. So after all that bending and bouncing, red light always comes out of a water droplet at a very specific angle, about 42 degrees. This means your eyes will only see red light from the raindrops that are positioned at exactly that 42-degree angle relative to you and the sun. And what about violet light? Well, since it bends more, it comes out at a slightly smaller angle, about 40 degrees. So you will only see violet from the droplets that are at that exact 40-degree angle. All the other colors of the rainbow fall somewhere in between those two. And this is where it all clicks into place. There are millions of droplets out there, all splitting light into colors. But you only see the color from the drops that happen to be in the perfect position to send that specific color right to your eyes. The collection of all the droplets at 40 degrees forms the red arc you see, and all the droplets at 40 degrees form the violet one. It's an arc made of countless points of light, all arranged just for you. And this physics leads to some other really cool things. For one, a rainbow is actually a full circle. If you're high enough, like in an airplane, sometimes you can see the whole 360-degree ring. And have you ever seen a fainter second rainbow?
That's caused by light bouncing twice inside the droplets, which actually reverses the order of the colors.
So, okay, it's cool science. But why does any of this matter? Well, it turns out that the same basic rules of light that create a rainbow are actually fundamental to a lot of our modern technology, and they even give us a pretty profound insight into how we see the world.
That science of dispersion, scientists use it in spectrometers to analyze the light from stars billions of miles away to figure out what they're made of. It's absolutely critical for our fiber optic internet. And designers of camera lenses have to engineer ways to correct for these very same color-splitting effects just so we can get a sharp picture.
Ultimately, it all comes back to this one simple, powerful idea. This quote just says it all. A rainbow isn't a static thing just sitting there in the world. It is a dynamic event, a process that is happening in real time.
It really is this fleeting, personal experience created by a perfect, momentary alignment of the sun, the water, and you. The actual water droplets that make the rainbow you see are constantly falling and being replaced by new ones. But as long as the geometry stays the same, the illusion of that stable, beautiful arc remains. And that kind of leaves us with a final thought to chew on. A rainbow is this beautiful, powerful reminder that so much of what we see is a direct result of our own unique position and perspective. It really makes you wonder, doesn't it? What other parts of our reality might look completely different if only we changed where we were standing.